wound rotor induction generators for wind energy conversion systems. This type of wind turbine, also referred to as a Type 2 turbine, uses a wound rotor induction generator. Wound rotor induction generators for wind energy conversion systems. This generator is different from the squirrel-cage induction generator because it has windings on the rotor that are not short-circuited and which can be accessed via slip rings and brushes as shown in figure in next slide. Topology of a Type 2 wind generator. A thyristor-based soft starter power electronics converter is sometimes used, which is not shown here because it does not affect the steady state operation. Also not shown is the parking brake. The rotor windings are then connected to an external three-phase resistor bank. The resistor bank contains variable resistors which we can control from 0 to maximum resistance R subscript E per phase. For higher reliability, we avoid using mechanically varying resistors. Instead, this control is achieved with a suitable power electronics converter. The actual resistance has a fixed value, but the electronics make it look like it is variable from the rotor side. A variant of this topology is one where the external resistors and power electronics are mounted on the machine's rotor. This eliminates the slip rings and brushes, which require regular maintenance. But now, control signals must be transmitted wirelessly to the rotor for adjusting the external resistance, and extra heat is dissipated inside the rotor. This makes cooling the machine more challenging. Request: it is hoped that this session is going to be useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा। Equivalent steady state circuit of the wound rotor induction machine. Analyzing the equivalent circuit. The equivalent circuit of this type of generator is shown in figure. There are two notable differences from the squirrel cage equivalent circuit discussed earlier. The first difference is that there is a variable external resistance R prime subscript E divided by S connected at the rotor side. Its variability stems from two sources, namely the slip and the fact that we can control its value R subscript E. The second difference is that the rotor parameters are now primed. For example, X prime subscript 2 or I prime subscript R. This is because all rotor quantities must be reflected to the stator side in exactly the same manner as for the transformer's equivalent circuit. The transformation depends on the turns ratio between the stator and rotor windings. In particular, if the external resistor has an actual value of R subscript E ohm, then the value used in the equivalent circuit is R prime subscript E equal to N subscript S divided by N subscript R whole square multiplied by R subscript E. Similarly, the reflected I prime subscript R is equal to N subscript R divided by N subscript S multiplied by I subscript R. This circuit can be solved using the same methods that were applied to the squirrel cage machine. We just need to substitute R subscript 2 by R prime subscript 2 total equal to R prime subscript 2 plus R prime subscript E in the equations. In particular, the rotor circuits and the external resistance waste an amount of power equal to 3I prime subscript R whole square into R prime subscript 2 total as heat. The other component 3I prime subscript R square multiplied by 1 minus S upon S again multiplied by R prime subscript 2 total is related to electromechanical energy conversion. The salient characteristic of a wound rotor induction generator is that its torque speed curve can be modified by adjusting the value of external resistance. This is classically illustrated with a plot such as the one in figure, which was obtained assuming that we have a 15 horsepower wound rotor machine with the same parameters as the squirrel-cage machine. The torque speed curve is stretched outwards by increasing R subscript E. It turns out that the peak points occur for values of slip that are directly proportional to R prime subscript 2 plus R prime subscript E, and that the corresponding pull-out torque remains constant. Torque speed characteristic of a wound rotor induction machine for external resistance R prime subscript E equal to 0, 0.1, 0.2 to 0.7 ohm, etc. Wind energy conversion with wound rotor machines. Power speed characteristic of a wound rotor induction machine for external resistance R prime subscript E equal to 0, 0.1, 0.2 up to 0.7 ohm, etc. Nevertheless, for wind energy conversion, we are more interested in the power speed curve, which has the interesting shape shown in figure. Apparently, we can use this property to operate this generator as a variable speed wind turbine, which will allow us to capture more energy out of the wind stream. What we want is to match the wind's power output at any given wind speed with the appropriate external resistance in order to operate at the optimum tip speed ratio. Set points of external resistance, stator power output and efficiency. In this table we can see that for each value of wind speed, the value of external resistance is being changed, and subsequently the power output is changing and the efficiency is also changing. Request: it is hoped that this session was useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा।